Hello, welcome back. We have been discussing the first unit of applied physics, that is quantum mechanics. In this video, we'll discuss the classification of solids basing on the electrical properties using the band structure of the solids. Solids can be classified into three major categories, namely the conductors, semiconductors, and the insulators. In these three different categories of solids, we notice that the energy band gap is going to change from insulators to the conductors. The bandwidth is coming down from insulators to semiconductors, and from semiconductors to the conductors it even becomes zero, which means the valency band and the conduction band, they overlap. That is the reason why we have high electrical conductivity for the metals or the conductors. So we'll first of all discuss the metals. In case of metals, the electrons in the outermost orbital, they move freely throughout the piece of the metal, and this kind of a movement is possible only when when the valence band is partially filled, B, a completely filled valence band overlaps with partially filled conduction band. In these two cases, the electrons can move freely within the piece of metal. We have drawn these two cases separately. The first case is partially filled valency band. If the valence band is so much and half of the valence band is filled by the electronic states and electrons, then these electrons can move freely within the band because the energy difference between the energy levels within a band is very small. Thereby these electrons can move freely through the piece of metal. In the second case, the partially filled conduction band is there and completely filled valence band is there. The partially filled conduction band will overlap the completely filled valence band. As a result, one can also have free movement of the electrons in the piece of metal. Example for the first case is sodium. For the second case, the example is zinc. Now we'll look at the second category, that is semiconductors. In the case of semiconductors, the forbidden energy gap exists. Energy gap is about an electron volt, close to 1 electron volt. We'll have the conduction band and the valence band with an energy gap or the forbidden energy gap which is about an electron volt. Materials with such a band structure are called as semiconductors. Their conductivity will be somewhere between that of the conductors and the insulators. The next category is insulators. In the case of insulators, we will have again the conduction band and the valence band, but the energy gap is quite large. It is about 5.4 electron volts in the case of carbon. In other insulators, it can go up to 10 electron volts. One can classify the materials using the band theory into insulators, semiconductors, and metals. In this video, we have seen how the solids have been classified using the electrical property and the band theory into conductors, semiconductors, and insulators. In the conductors, we'll have free electrons moving through the piece of the metal or the conductor, and this can happen only when the valence band is partially filled or a completely filled valence band overlaps with the partially filled conduction band. Under these two circumstances, one can have electrons moving freely through the entire piece of metal. The partially filled valency band and the partially filled conduction band and completely filled valency band are shown in this diagram here. Sodium is an example for partially filled valence band case, and zinc is an example for completely filled valence band and partially filled conduction band. We have seen that if the energy gap is about an electron volt between the conduction band and the valence band, then we have materials that are classified as semiconductors. Similarly, when the energy gap is quite large, that is 5.4 electron volts in the case of carbon, and in some other cases it is about 10 electron volts, such solids are classified into insulators. Thank you.